Hi everyone, we're excited to showcase our transport layer security solution. There are two parts to the TLS presentation. The first part describes the introduction of TLS 1.3 protocol, including what is TLS, why TLS is important, and how TLS works, and introduces DG's solution. The second part describes the TLS 1.3 demo. Let's start with the second part. TLS1G demo showcases the utilization of DG's security IP core, including AES-256G CMIP, to establish a secure connection using the TLS 1.3 protocol. The TLS1G demo is designed to work as a client and is compatible with general servers like Node.js. User can use TLS1G demo to establish a connection with an HTTP/HTTPS server, just like with a web browser. The demo system consists of a server, web browser, and TLS1G demo, all connected together through a network. TLS 1.3 demo implemented on AC701 board. It is designed to create a connection with HTTP/HTTPS server. For a secure connection, TLS 1.3 is implemented over TCP/IP. The supported cryptographic algorithm for the demo are X25519 for key exchange, hash-based key derivation function or HKDF with SHA-384 for deriving keys, AES-256G CM for encryption decryption, and RSA for certificate verification. In this demonstration, users can set parameter which are the IP address, port number, and MAC address of the FPGA board, enable hardware, enable Shoki mode, and download and upload data by using the supported command. To set parameter, the user can use set IP to set FPGA's IP address, set port to set FPGA's port number, set MAC to set FPGA's MAC address, set hardware to enable hardware for handling the connection, Shoki to show TLS traffic ticket, session key, and initialization vector for encryption. To download data, myget following by URL is used. To upload data, mypost following by URL is used. A sample server is created using Node.js that utilizes the HTTP protocol to communicate with clients. When running the Node.js server, the server's IP address for all network interfaces will be displayed on the console. Clients can download data from the server through the use of the GET method, and upload data to the server via the POST method. For downloading data, users can use GET method to download 4 different data patterns or HTML pages from log folder by inputting the corresponding URL. After transferring completed, the server console will display the type of requested data pattern as well as the length of the downloaded data. For downloading data via a web browser, when a user inputs a URL into a web browser, the requested data is downloaded and displayed. For example, if a user requests the dg.html file located in the log folder, the contents of the dg.html will be displayed. Similarly, using the myget command followed by the same URL that was input into the web browser to download the data, you can see the same data displayed on the serial console. For uploading data, the user use POST method transfer data pattern. After transferring completed, the server console will display the length of the data, and transfer speed as well as the received data if the data length is less than 16 KB. To upload a data pattern to the server via a web browser, users need to request the upload menu to generate a data pattern, which can then be sent to the server using the HTTP POST method. Users can select the type of data pattern and its length and then push the POST button to initiate the upload process. Once the transfer is complete, the server console will display details of the transfer, the data length, and transfer speed. If the data length is less than 16 KB, the received data will also be displayed on the server console. To upload data to the server via TLS1G demo, the user can input mypost command followed by URL into the serial console. This command simulates POST method of HTTP and generates a data pattern to upload data to the server. Once the transfer is complete, the serial console will display the length of the data and the transfer speed. On the server console, you'll also be able to see the data length and transfer speed. If the length of the received data is less than 16 KB, it will be displayed on the server console as well. When the connection is secured, TLS 1.3 protocol is implemented. the client must handle cryptographic algorithms for handshaking and transferring data. High-performance controllers, such as the CPU on a PC running web browsers, can handle these connections with a throughput of nearly 1 gigabit per second but consume around 10% of Intel i7 CPU usage. However, low-performance controllers, such as the Microblaze in AC701, are not capable of handling the TLS1.3 protocol to achieve 1 gigabit per second throughput. In fact, the transfer speed between the server and AC701 is dramatically decreased when handling TLS1.3 with firmware. By hardware accelerated, hardware in the TLS1G demo can recover the transfer speed to nearly 1 gigabit per second and act as an offload engine, allowing the CPU to handle other tasks. This means that not only can you secure your communication with TLS 1.3 with no overhead time, but you can also free up resources for other important tasks. For more information about our TLS 1.3 solution, please visit our website designgateway.com, or click the link in the description below. Thank you for watching and see you in the next video.